Hey everyone, welcome back to CAD Tips and Tricks with Smart Design. My name is Nick, I'm a senior design engineer here at Smart, and today we're going to talk about non-planar parting lines. Now in the last video we talked about planar parting lines, but this time around it's a little bit more complicated as there's a few more steps on the front end. Once we get to making our parting line though, the process after that is fairly similar. Today our model is asymmetric, and so we're going to be building two unique surfaces to walk through this process. I'm going to get right into the master model to talk about the construction. And so to build a non-planar parting line, we're effectively making a 3D curve. Now you can make a 3D curve simply by making a 3D spline, but today I'm actually going to build it differently by making multiple 2D curves on different 2D views. And that's just going to make things a little bit easier to control and modify, but it is a few more steps. And so the first step I'm doing is simply making a planar spline on my side plane. This is what my parting line is going to be from this view. Now I'm going to extrude this out. And in Creo, I'm going to do this in style by offsetting the curve and building a surface between the curves, but this is identical to extruding the surface. After this, I'm going to reference a sketch I made before this style feature. So you can see there are these two lines here in this frame sketch, and I'm going to project them onto the surface. That's now giving me two curves on that surface that I can use to reference as anchor points for the next step, which is making a spline on that surface. I'm going to snap to my top view here. And right now I'm making the top view of my parting line, and it's on that curve that was extruded from my side view. And so here I can just focus only on this view, but when I hide everything else, you can see that this is my 3D curve and this is my parting line for the rest of the model. Now that I have my parting line, I need to create a reference surface just like last time. I'm also using a sweep again, but the section this time has two segments. Again, the length is arbitrary of each segment. I have each segment drafted, but there needs to be two because I'm creating two different surfaces, one on the top, one on the bottom. The top surface is going to reference my bottom segment. The bottom surface is going to reference my top segment. The other really important step here is making sure that your sweep is normal to projection, not normal to trajectory. So what that means is that you need to maintain the 1.5 degrees draft of your sweep by referencing my top plane as my normal direction. And so I always have that 1.5 degrees. If I make it normal to trajectory, then that 1.5 degrees will become variable relative to my top plane by following the path of the actual curve. After this, I'm going to build out my surfaces. And this is where it gets really similar to last time. You're building out your wireframe. You're making sure that all of your splines are surface tangent to your swept reference. This time again, it's just that bottom section. And then you can build out your top surface. That top surface is tangent to that section of the sweep. Same thing goes for the bottom. You're going to create all of your bottom curves here. Make sure that you have your surface tangent reference to the top section of the sweep. That'll let you then make the bottom surface. And that is tangent across the whole edge on your swept reference. The rest of the model is just closing the volume. And in the part file here, you can see that we have a really clear tangency break. You can see that sharp edge. And when I do a quick draft analysis here, you can see we have a clean, crisp parting line. Again, you just edit that sweep and you can edit the draft angle on both the top and bottom surface. That covers it for today. Thanks so much for joining, and I'll catch you on the next one.